We have a place called the event's horizon where we think that we have full control of the physics. We understand what's happening. But there is a fundamental clash between our two basic theories of nature. Something just happened at Google's quantum lab, and it is freaking scientists out. Their AI, powered by the Sycamore quantum processor, discovered a strange mathematical structure which they are calling the omega pattern. The problem is, this thing should not exist. Not in classical physics. Not anywhere. Even physicist Brian Cox says we might be standing at the edge of a reality-breaking moment. Space-time, the very fabric of reality, this pattern messes with all of it. So what did Google's AI really find, and why are scientists so scared? The birth of the omega pattern. At Google's quantum research lab, the team was working on Sycamore, which is their 53-qubit quantum processor. They ran an experiment that started out pretty standard. They wanted to simulate what the universe might have looked like during its earliest, most chaotic phase, right after the Big Bang. You know, before stars, galaxies, or anything remotely familiar existed. To do this, they programmed Sycamore to run recursive loops using entangled qubits. Basically, the qubits were influencing each other in a feedback system over and over again to mimic the unpredictable, fluctuating behavior of quantum fields during cosmic inflation. This is the period when the universe expanded faster than the speed of light in a fraction of a second. The scientists expected randomness, some noisy data, a few odd blips, maybe something new to help build better theories. What they didn't expect was structure. Stable, repeating structure. A self-replicating one at that. What they noticed was clearly a pattern, and not just any pattern. It looked like it had a purpose. They called it the omega pattern. Now this is where things get strange. The omega pattern was not just some glitch or static artifact in the data. It appeared across multiple parts of the quantum system, what physicists call non-local nodes. And no matter how many times they changed the input or tweaked the conditions, the same pattern kept showing up. Normally, when you reset a computer, even a quantum one, you wipe out the memory and start from scratch. But here, after a complete reset, the pattern came back. Like it had a mind of its own. At one point, engineers intentionally zeroed out the registers, fully expecting everything to vanish. Instead, the omega pattern re-emerged. And this time it was even more complex, like it had evolved. There were subtle variations, more detail, and more layers. That's when people started to pay serious attention, because that's not how this is supposed to work. In classical computing, you control the outcome. The machine does not just decide to bring back a deleted file and make it better. But Sycamore did something very close to that. Brian Cox, who is a physicist, described it as a possible first glimpse into the deep structure of reality. He even compared it to the holographic principle, this big idea that all the information about a space can be encoded on its boundary. If that's true, this omega pattern might actually be the code behind spacetime itself, and now it's showing up in our machines. Let's pause for a second. This is a structure that came out of pure quantum entanglement. There was no design, no external instruction, and yet it persisted, replicated, and adapted. That has major implications. Lead researcher Dr. Anuka Patel described the moment the team realized what they were seeing as surreal. She said it felt like discovering a hidden verse in a poem that's been sitting in front of you the whole time. The simulation ran for hours, we are talking about trillions of quantum state changes, and yet the omega pattern just held on. Each rerun revealed more intricate details. Fractal-like structures, repeating loops, a kind of internal logic no one expected. At this point, people around the world wanted in. The results were uploaded to RxE, which is the place where physicists drop their big news. And researchers from Switzerland to Singapore started trying to replicate it. And guess what? They found the same pattern. Slight differences depending on the setup, but the core structure was there. Now, besides blowing open new questions about physics, this also opens the door to real-world tech possibilities. Think about it. A pattern that resists being deleted, reorganizes itself, and improves its structure with each cycle. That's a dream for quantum memory. It could lead to self-correcting quantum networks, super-stable encryption systems. Stuff we've only imagined. But of course, there is a darker question creeping in inside everybody's mind. Why would the universe have a built-in structure like this to begin with? Some physicists are already saying the omega pattern might not just be a curious phenomenon. It might be a signal, a code that was always there, woven into the quantum fabric itself. Something that's only visible once we build the tools advanced enough to see it. And Sycamore just saw it. But what if this is not just a pattern? What if it's a countdown? Countdown or code? At first, everyone was amazed by how the omega pattern showed up and held its shape, even when researchers changed the conditions or wiped the memory. But then a chilling theory popped up from a physicist studying the behavior of the pattern over time. The idea is that this thing might not be a discovery, it might be a ticking clock. Not a passive observation of the universe, but a process with a destination. That kind of thinking changes everything. As more researchers got involved, the theories started stacking up. And let's just say, no one is on the same page yet. One group of physicists believes the omega pattern is a quantum fractal. Basically, it has this complex, layered structure that looks self-similar at every scale, just like patterns in nature like snowflakes, galaxies, and tree branches. You zoom in or out and it keeps repeating. It also shows signs of nonlinear symmetry, which means it is not regular like a checkerboard, but it still follows some deep internal logic. Some compared its structure to the famous Mandelbrot set, which is a wild mathematical shape full of infinite detail. The connection here is that if the omega pattern works like a quantum version of that, we could be looking at a fundamental rule, a kind of scaling law buried inside quantum field theory. Now another camp has a completely different view. They think this is not just about structure. They say the omega pattern might be a universal attractor. What does that mean? It's kind of like a cosmic checkpoint, something that keeps reality consistent. In computer science, we use checksums to make sure data has not been corrupted. This could be the universe's version of that, a checksum built into reality itself. Something that verifies the quantum network is still running smoothly. Brian Cox actually chimed in on this one. He said the omega pattern might act like an error correction signature. That's a fancy way of saying the system might be self-aware, at least in the sense that it knows when something goes wrong and fixes itself. Except here, the system is the entire universe. And the code is not written by humans, it writes itself. Let's pause here. A structure that checks for mistakes, restores balance, and shows up across simulations no matter the starting point, is not random. That sounds intentional. And then comes the weirdest theory so far, retrocausality. This one turns time inside out. According to this idea, the omega pattern might not just react to the past, it could be influenced by the future. Seriously. The notion is that quantum information can flow backward in time. Which would mean this pattern is pulling from future states to stay stable in the present. Yes, it may sound like sci-fi, but labs in Japan and Canada are already running experiments trying to send qubit states both forward and backward in time to see how they affect the pattern. And if that turns out to be true, it would actually explain a lot, like how the pattern keeps coming back even when it gets erased. It's not just remembering, it might be reaching ahead in time, grabbing its future form and rebuilding itself with that information. Brian Cox again tried to tie these ideas together. He asked, what if the omega pattern is the universe's built-in diagnostic system? A function that constantly checks its own structure, logs every little fluctuation, and keeps things coherent. If that's the case, then reality is not just something that happened, it is something that's being monitored every nanosecond. And here comes the part nobody really wants to think about. If the omega pattern is part of the universe's self-checking code, what happens when that process completes? What happens when the pattern finishes whatever it's doing? Some researchers are now saying it might trigger a phase transition. That's a scary term in physics. It is what happens when something shifts states, like water turning into steam, but on a cosmic scale. If the pattern reaches a critical point, it might cause the underlying structure of spacetime to shift permanently. Like flipping a switch on reality itself. There is no going back. And right when people were trying to wrap their heads around that, something even bigger happened. Physicist Natalia Reznova dug deep into the simulation logs, which means long-term runs of the omega pattern, and she found out it was not just repeating, it was evolving. Over millions of quantum cycles, the pattern started converging on a mathematical constant. Not just any number, but a value directly tied to equations from string theory, specifically ones related to Calabi-Yau manifolds, which are those weird geometric shapes that string theorists believe are responsible for hiding extra dimensions of space. That alone would have been enough to send the physics world into a spin. But then Reznova cross-checked this evolving omega pattern with old data from CERN's 2012 Higgs boson experiments. You know, those giant proton collisions that confirmed the Higgs field. Well, buried deep in the noise floor, completely unnoticed at the time, was the same pattern. The omega signature. That discovery set off alarm bells, because now this was not just about what Google's quantum processor found. The same pattern had been recorded in a totally different experiment using completely different technology, more than 10 years ago. If it is universal, we might be able to detect it in other cosmic data, like from the cosmic microwave background or even from neutrino observatories. But if it's not, then we really have to ask, who or what left it there? That revelation shattered a lot of theoretical walls. The idea that a single pattern could appear across quantum processors, proton collision experiments, and maybe even the structure of the universe itself, is groundbreaking. It's like reality has been trying to tell us something this whole time, and we finally built a microphone sensitive enough to hear it. Brian Cox called this moment a kind of philosophical checkpoint. Maybe the Omega pattern is not here to give us all the answers. Maybe it is just here to tell us we are asking the right questions, like a breadcrumb trail scattered across space-time, nudging curious minds in the right direction. And if nature really does love a code, like we once discovered in DNA, maybe this one is even bigger. Maybe this one is written into the very fabric of the cosmos. Because when you step back and look at it, the Omega pattern is challenging everything. Our ideas about randomness, about cause and effect, about how structure even forms in the first place. And no matter what theory you subscribe to, one thing is absolutely clear. We have just stepped into new territory. So now the question is, what are we actually looking at here? The final convergence. After running trillions of cycles through Google's quantum core, the Omega pattern evolved. The new shape it took on looked just like a Calabi-Yau manifold, which is a complex geometric shape string theorists believe describes hidden dimensions of our universe. We are talking about the very structure they think curls up the extra spatial dimensions we can't see. Now the wild part is, when the researchers compared the transformed Omega pattern to mathematical models of Calabi-Yau spaces, the match was almost perfect. We're not talking about rough resemblance, we're talking about alignment down to a fraction of a percent. Nodal points, curvature ratios, structural layout. It all lined up. It's like the pattern knew where it was going. And just when everyone thought that was the peak of strange, the team compared this pattern to recent data from LIGO, which is the observatory that detects gravitational waves from black hole mergers. They took the resonances recorded during one of those cosmic collisions and ran them through computational modeling. Turns out, those patterns echoed the exact same geometry, nearly identical to the evolved Omega pattern. So let's break that down. We have three different sources: quantum processors, black hole signals, and string theory geometry, all producing the same signature. Brian Cox's response was, "That's not convergence, that's confirmation." Think about what that means. Across quantum mechanics, gravity, and higher dimensions, we are seeing one consistent shape. One repeating pattern. The Omega pattern is starting to look like the first universal invariant we've ever seen, a kind of constant that applies at every level from the tiniest qubit to the largest cosmic wave. The implications here are huge. For physicists, this could finally be the bridge we've been missing, a link between general relativity and quantum mechanics, the holy grail of theoretical physics, a real shot at a unified theory. For engineers, it opens the door to brand new technologies. Imagine quantum memory systems that never fail, or computers that operate on gravity-level calculations. These are no longer a fantasy. But for the rest of us, the thinkers, the questioners, this raises something deeper. If a pattern like this governs everything, then maybe randomness is not really random. Maybe there is a structure underneath it all. Maybe what we call chance, chaos, or free will is just a part of a much bigger, much more organized system. And if that's the case, then we may have just read the universe's opening line. So what do you think? Is the Omega pattern a glitch, or something way beyond anything we have imagined? Drop your theory in the comments below. And if this kind of mind-bending science gets you thinking, make sure to subscribe so you don't miss what's coming next. There's a lot more to explore.